Okay, lesson 32. Okay, quotient theorem for square roots, congruency, and congruent triangles. So let's start with simplifying this lovely radical. So it's the square root of 3/7. The first thing you want to do is like write it as separate radicals. So if you're doing the square root of 3/7, that means the same thing as the square root of 3 over the square root of 7. So that's how I would write it down, because then this looks like a doable problem. Okay, so separate your square roots. Now we just rationalize the denominator just like we did before. So I need to multiply by whichever one is in the bottom here, square root of 7 over square root of 7. Okay, if they're both under the house, they multiply, right? These are both underneath the radical, so this is the square root of 21. And then these are both under the house, so that's the square root of 49. And what is the square root of 49? Right. All right, and that's your answer for that one. Okay. Now we're going to add them together. So the first thing you want to do is write them down as separate like radicals, top and bottom, okay? So I'm going to actually just write it down from the book like this, square root of 3 over square root of 5. So this is the same thing as if I just do radical top and bottom, okay? Plus radical of 5 over radical 3. First, we want to rationalize the denominator separately, okay? So Simon, what should I multiply this first one by to rationalize the denominator?
Root 5 over root 5.
Exactly. I want to multiply this one by root 5 over root 5. And Izzy, what should I multiply this one by?
Root 3 over root 3.
Exactly. Root 3 over root 3. All right. So now I multiply, and they both are underneath the radical. So this is root 15. And you can skip this little step. You guys, you know, this is the square root of 25, which is 5. I would just do 5, right? Okay, root 5 times root 5 is the square root of 25, which is 5. All right, now on the top here, I get the square root of 15, 5 times 3, over, this would be the square root of 9, which is 3. So rationalize your denominators, then get common denominators just like you would in normal fraction work, right? So Anders, what should I multiply this first one by? Exactly, 3 over 3. And Sophia F., what should I multiply the second one by?
5 over 5.
Exactly, 5 over 5. Okay, so now I have 3 root 15 over 15. And over here, I have 5 root 15 over 15. Can I add these together? Yes, we have common denominators, and they have the same radical in the top. Okay, so I'm adding 3 root 15 and 5 root 15. That's 8 root 15 over my common denominator. Okay. What if there's a little number in front? Okay, I recommend you put it in the numerator. Okay, so the first thing you want to do is like the 2 that's out front is really like a 2 over 1. So I'm going to write this as 2 root 2 over root 7. So you split your radical, top and bottom, okay? And you keep that whole number in the numerator. Minus 3 root 7 over root 2. All right, so split your radical, top and bottom, put that whole number in the top. Now we do the same thing we were doing before. So Christine, I want to rationalize. What should I multiply this one by?
7.
Close. Root 7, but yes, root 7 over root 7. You guys agree? Okay, Alex A., what should I multiply this one by to rationalize the denominator? Root 2 over root 2. All right. Now again, when you multiply these, you got to be careful with what multiplies to what, right? So you only multiply under the house to under the house, like under the radical to under the radical, okay? So Will, what do I get on top and bottom here?
It's 2 root 14 over 7.
Good. And Rowan, what do I get top and bottom here?
3 root 14 over 2.
Good. Actually, a lot of people miss this one. A lot of people put 4. on the one we do on the board. So make sure you do square root of 4, right? Which is 2. All right, now we need a common denominator. So Sophia R., what should I multiply this first one by to get a common denominator? Yep, so I'm going to do 2 over 2. And Sophia D., what should I multiply this one by? 7 over 7. Now again, these are outside numbers, so they are only multiplying to the outside numbers, not the radical. All right, so I get, Ariana, what do you get for the first one?
4 root 14 over 14.
Yep. And Addie, what do I get for this next one? Exactly. Okay. And now I can subtract. I have a common denominator at the same radical. So 4 minus 21 is negative 17. And then we keep our root 14 over 14. Okay. Just a bunch of radicals and fractions. All right, congruent triangles. Go ahead and draw this lovely picture on your piece of paper. Anybody notice anything just from the picture that we can mark congruent? James? Oh, Alex? Yes. The 4 side. Very good. So right here, you guys, I know that 4 equals 4, right? Weird. I know. So I put a little tick mark there to be like, yep, those are congruent. Yep. Yes. So you guys, they marked that with the little arrow thing, which means that these are parallel. So I have parallel lines with this lovely transversal here, meaning that this angle is congruent to this angle by alternate interior angles, okay? And this angle is congruent to this angle by alternate interior angles. So they alternate the transversal and they're inside the parallel lines. There is one more thing from the picture that's congruent. Debke? Yes. Okay, I have vertical angles here, right? V, A. Okay, so if I have 3 equal angles and 1 equal side, this is one of the triangle theorems that you don't have to know for now, all right? But we will learn these eventually, okay? Angle, 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 side tells us we have congruent triangles, all right? Because I know if I have 3 congruent angles and 1 congruent side, I definitely have congruent triangles. And what's cool is if I have congruent triangles, then everything else that's not marked is congruent, right? Like every other side is congruent. I already did all the angles. They're all already marked, right? And I know the 4s are equal to each other. So now what else do I know is equal? How about across from those vertical angles? Okay, these 2 sides are equal. So I could write down that P is equal to 4x minus 1. Everybody agree? Okay. And I also know now that opposite my 2 side is equal to opposite my 2 angle, right? Those 2 angles that are equal, opposite of those sides are equal. So I can say that 4x plus 1 equals 12x minus 7. All right? And we want to solve now for x. So I'm going to subtract 4x from both sides. That's 8x. And I'm going to add 7 to both sides here. That's 8. I'm going to divide both sides by 8. So x is 1. All right. Which means I can then find p over here, because I can substitute in a 1. 4 times 1 is 4. Minus 1 is 3. So p is 3. Now, what's my reasoning? My reasoning for this whole thing is called Cpctc. You have to say it like that. You have to say it like that. Cpctc. All right, here's what it stands for. All right, write that down. Cpctc. This stands for corresponding parts of, I'm going to shortcut this. Do you guys know this? Congruent. That's what that means. Triangles are congruent. If you don't know what that means, you might want to write down congruent. That's why you can write Cpctc.
It's so much for an acronym.
All right. Corresponding parts of congruent triangles are congruent. How many times is the word congruent in there? Twice. There are 3 C's, but the first one is corresponding. All right. What does this mean, you guys? What does this mean? Corresponding parts of congruent triangles are congruent. Let's say that I know these 2 triangles are congruent. And let's just say it's marked like this, where I know only this, right? That's side angle side. If I know those are congruent, what else is congruent? That side, those angles, everything else is congruent. That's all it means, okay? I can just set whatever I want equal, all right? As long as it's corresponding parts, meaning like same sides, right? That's it. Corresponding parts of congruent triangles are congruent. Cpctc. All right, let's try a whiteboard. Okay. Go ahead and try the next one. All right, you guys. Last one is this one.